So today this video is regarding few of the queries which was sent to me by class 11 students, and this belongs to chapter number 1, the basic chemistry, basic concepts, stoichiometry, mole calculation and so on. So let's go one after another. So first question is what? At STP, calculate the amount of volume ammonia formed, its volume and moles. If 15 liter of H2 gas is consumed, so this just shows that it is nothing but what? Haber's process, N2 plus 3H2 gas gives twice NH3 gas. Simple, this is stoichiometric calculation, might be limiting reagent, but here a data of only one reactant is given, so we take it for granted that whatever is required, the another amount, it is there. So they are asking what will be the amount of ammonia if 15 liter of H2 is consumed. So V liter of H2 is given 15 liter. And as they are talking about volume, we put the standard data at STP, because we know 1 mole at STP is equal to 22.4 liter. So 3 moles are there. So 3 multiplied by 22.4 liter, that gives what? 2 multiplied by 22.4 liter of ammonia. Simple. So what about if 15 liter of H2 is consumed? So we can write 3 multiplied by 22.4 liter is equal to, or H2 of H2 is equal to 2 multiplied by 22.4 liter of ammonia is formed. So what will the volume of ammonia 15 liter of H2 is consumed? So what we can write is equal to 15 multiplied by 2 multiplied by 22.4 divided by 3 multiplied by 22.4. So it is what? 10 liter of ammonia is consumed. So, amount of ammonia, I don't know whether it is gram or number of moles. So we can convert this liter into mole also, and ultimately we can convert into what? Acha, mole is here. So might be mass. So 1 mole is equal to 17 gram, that is its molecular mass, is equal to 22.4 liter. So 10 liter, what is the mass? So 22.4 liter is equal to 17. So 10 is equal to 10 multiplied by 17 divided by 22.4. That will be the mass of ammonia formed. Okay. Number of moles, 22.4 liter is equal to 1 mole. That's why 10 liter is equal to how many moles? 10 liter divided by 22.4 liter. Whatever the answer comes, 10 divided by 22.4, 0.4464, moles. And if number is asked, then 0.44 multiplied by Avogadro number will be the number of ammonia molecules. You can find anything, number of moles, mass, molecules, anything. Now let's come for the second. Here, rather than volume, directly numbers of N2 which are consumed for the same reaction is given. N2 plus 3H2 gives what? Twice NH3. This is one of the reactions. Calculate the associated volume of H2 consumed. They are nothing asking about product, but they are asking if these many molecules of N2 are consumed, then what is the volume, what is the mass, and what is the number of molecules of H2 consumed. So he can put the number here. It is 1 mole, that means 6.022 into 10 raised to 23N2. Make sure your reaction should be what? Balanced chemical reaction. Then you have to correlate the standard data. So here 3 moles are the 3 multiplied by 6.022 into 10 raised to 23 molecules of H2 are there. Okay. So if these many N2 reacts, these many H2 are required. So if these many N2 reacts, then how many H2 are required? So we can write, that's why if 3.01 is to 22 are there, then how many H2 are required? So 3.011 into 10 raised to 22 multiplied by 3 into 6.022 into 10 raised to 23 divided by 6.022 into 10 raised to 23. This is cancel. So 3 3s are 9. 9.033 into 10 raised to 22. These many molecules of H2 required. Okay. Now they're asking volume. So what we did in last, that we'll do here. Before that, we need to find the number of moles. Well, or we can go directly also. Number of mole is equal to what? Number upon Avogadro number. So number of molecule is 9.033 to 10 raised to 22 and 6.022 into 10 raised to 23. So here it will be 9.033 divided by 6.022. So it is what, 1.5. So 1.5 into 10 raised to minus 1. 23 will be minus 23. So 0.15 moles of H2 is required. Now find the volume. So 1 mole is equal to 22.4 liter, and that's why 0.15 is equal to how much? So 0.15 multiplied by 22.4. So that will be the answer in liter. That is the volume of H2. Let's go for the third one. Yeah. This is as similar as the numerical in the textbook exercise of welding fuel is there. You know, the question is asked about the empirical formula. इसका एम्पिरिकल फॉर्मूला तो बोले एक हाइड्रोकार्बन है. हाइड्रोकार्बन मानो उसके अंदर एक हाइड्रोजन है और एक कार्बन, ओनली 2 एलिमेंट्स आता है. नाउ either we required percentage or directly we require the mass of this carbon and hydrogen which is present in this hydrocarbon, but we are neither given this nor this one. But the reaction is given when this hydrocarbon combust in presence of oxygen. Obviously there would be only two products, CO2 plus H2O, along with heat released. So the mass of CO2 produced and the mass of H2O, that is given. This 0.72 and this is 3.08 gram is given. Now see, to find out the empirical formula, we know we need to draw one table. And here we'll write the elements, that carbon and hydrogen. Then here we'll write the masses of carbon and hydrogen which is in the hydrocarbon. Then we'll write the atomic masses. The fourth column will be number of moles. Then this will be what? A ratio of number of moles. And if it is not simple, then we'll make it simple ratio. So we require the masses because we know this is 12 and this is 1. So here we have to apply a law of conservation of mass. As on the left hand side, the hydrocarbon is only one who contains carbon and hydrogen. On the right hand side, carbon dioxide is there which contains carbon but nobody else that contains carbon. The same way water is only there which contains what? Hydrogen. There is no other product which is having hydrogen in it. That means whatever the mass of hydrogen in water is there, that will be the mass of hydrogen in hydrocarbon as per the law of conservation of mass. So students only know that the law of conservation of mass is what? The total mass of reactant is equal to total mass of product. But it is not true. It is true, but there is another thing is also there. Whatever the mass of one element is on left hand side is there, that will be the mass of element in the right hand side. So there is no other product which contains carbon than only CO2, and the mass of CO2 is given. So you have to find out the mass of carbon in this 0.72 gram of CO2. How can you find? So simple step. The molecular mass of CO2 is 44. 44 gram of CO2 that contains 12 gram of carbon as per the molecular mass. That's a 0.72 gram contains how much carbon? 0.72 multiplied by 12 divided by 44. Let's do what it comes. 0.72 multiplied by 12 divided by 44. It comes 0.19. Okay. Go for here. Water. 18 gram water. It contains 2 gram hydrogen, and that's why 3.08 gram. Water contains how much hydrogen? So 3.08 multiplied by 2 divided by 18. Again, let's do 3.08 multiplied by 2 divided by 18.34 gram. And this is what? Sorry, hydrogen, and this is what? Carbon. So let's put 0.19, and this is what? 0.34. Number of moles, so 0.19 divided by 12, it gives 0.05, and this gives what? 0.34. So this will be 1, and this will be wait a minute, what was it? 12 divided by 0.19. Sorry, 0.19 divided by 12. It is 0.015. Okay. So here it will be 0.34 divided by 0.015. So it is 22. I think somewhere there is a mistake. 0.34 divided by 0.015. It is coming 22.66. Let me check, verify. 0.72 gram of water. Oh, CO2 mass is given. So here I have made a mistake. Let me correct it. So here I can write what? 44 gram CO2 that contains 12 gram of carbon, then 3.08 gram CO2 contains how much carbon? That will be 3.08 multiplied by 12 divided by 44. So now थोड़ा स्पीड में करना पड़ेगा 3.08 multiplied by 12 divided by 44, it comes 0.84. So that is what 0.84 gram carbon. Let's go for the hydrogen. So 18 gram water that contains 2 gram of hydrogen. That's why 0.72. How much? So 0.72 multiplied by 2 divided by 18. That's 2. 0.72 multiplied by 2 divided by 18.08. Let's go for the table. Let me make the table here. So carbon and hydrogen. Its mass is 0.84. Its mass is what? 0.68. What was it? 0.08. Okay, 0.08. This is 12. This is 1. This will be 0.08. This will be I think 7. 0.84 divided by 0.07. So here what I will do, this will be 1 and this will be 1.14. So I think 1.1 will remain 1.1 only. Approximately it is what? 1. So the formula is what? CH. Empirical formula will be what? CH. Now let's go for the next numerical. That's amazing, very interesting. What is this asked? It is asked that volume of CO2 which is obtained at STP by the complete decomposition of this many gram of Na2CO3. So what is the reaction actually? Na2CO3 when it decomposes, it gives what? When it decomposes, it gives what? Sodium oxide plus carbon dioxide. And the question is asked at STP when this is happening, then what will be the volume of CO2 produced if 9.85 gram of Na2CO3 is there? So here the answer is actually 0. You might be thinking how can it be 0? Is its molecular mass that gives what? 22.4 liter of CO2. So certain mass is there, certain volume will be there. But it is 0 because this is not a feasible reaction at STP. Very nice question, because this generally takes place beyond or around 500 degrees Celsius. So STP is not 500 degrees Celsius. So you got it? Because of this, the answer would be 0 because reaction ही नहीं होगा, तो volume कैसे मिलेगा? And this is also very short and simple. What is this numerical? Just wait. Here, ammonia gas is passed through water. And we know when ammonia is dissolved in water, it gives a weak base NH4OH. So that is formed. And when this is formed, the density of this ammonium hydroxide solution is found to be 0.93 gram per centimeter cube. Okay. And the solution which is prepared, its percentage mass by mass is 18.6 because by weight is given. What they are asking. what would be the mass of ammonia which is dissolved per centimeter cube? So it is very simple. What is the interpretation of this is 18.6 gram of ammonia is present in 100 gram solution. Now whatever the amount is asked, it is not per gram per centimeter cube per ml is asked. So anyhow you convert this 100 gram into volume. So density is equal to mass by volume, and that's why volume is equal to mass by density. Mass is 100 divided by its density is given 0.90. So let's find what is the answer. 100 divided by 0.93. It gives 107.57 ml. So simple. That's why I can write 18.6 gram ammonia is dissolved in 107.57 ml of solution. So here I can write, that's why how much ammonia would be there in 1 ml. So 107.57 is equal to 1 ml is equal to 18.6, that right? That's why this one is equal to how much? What we'll do? So 107 divided by 18.6, that becomes 5.7. 5.7 gram of ammonia would be there in 1 centimeter cube, you know, of this solution. If this 1 centimeter cube, 1 ml. So here is the end of the all queries which was sent to me. So you can also send your questions. As I get the time, I'll make the video and I'll send you back.